Hello everyone. Today let's solve the problem number 200, number of islands. Right. So what the question states here, we are given an m into n binary 2D grid. Right. So you can clearly see here we are given an m into n 2D grid representing the land as ones. So all the ones present here as lands. Just keep this in mind. All the ones that is present in the grid here. One. You can clearly see here these ones, right? So these one basically represent the land and water represents 0 here. In this case, 0 is nothing but water. 1 is land, 0 is water. Just keep this in mind. So we have to count the number of islands. So we have to count the number of islands. Then what is an island? Basically, the condition they have given here or the requirement. Clearly listen to this. An island is a group of ones. An island is a group of ones connected horizontally or vertically. Either you can connect horizontally or vertically, right? Just keep this in mind. And completely surrounded by 0. And completely surrounded by 0. It is completely surrounded by 0, right? So an island is a group of ones connected horizontally or vertically and completely surrounded by 0. We shouldn't be considering the diagonal ones, right? So we should consider either horizontally or vertically. They have clearly mentioned in the question. And completely surrounded by the zeros. I hope this is clear, right? So just give me a second. Let's come to the first example. So here in this case, we'll start from here. So we can move vertically here. We can move one step left, then this one. What do you call? Down, right, and right. So this forms the island, right? This forms one complete island. There is only one group of it, right? So there is only one group of it. In this case, we have to return 1, right? So I hope this is clear. Accordingly with the question and the requirement, we are doing this one. So for the first example, we got the output 1. So let's move on with the second example here. So here you can clearly see this one will move this one down and left, right? So this is one part. So next we cannot move diagonally, right? To consider this one, we cannot move diagonally. So this one we will consider different island, right? So we got 2 now. So we got 2 islands now. So here we cannot consider this one diagonally, right? So we will consider this one differently. We'll start from here and this one will move right. So this group, this is considered 1 basically, right? So we have 3 islands basically for within this grid, right? So now we have to return 3 in that case, right? So in this case we have to return 3. So yeah. So for the first one we got the output 1 and the second one we got output 3 here in this case, right? So I hope this is completely clear. Let me remove this one. So the output that we got here is 1 and 3, right? So I hope this is complete. So first let's discuss the approach followed by the edge cases one by one and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach first. So here the first thing that we need to note down here is we will be going with the DFS approach or depth first search, right? So I have considered the same first example that they have given in the question. The first example that they have given in the the first example that they have given in the question, right? So same thing. Let's see this. We have already discussed this one. We got the output 1, right? So let's move on with the step-by-step execution here. So the first part here is we will start scanning from the 0, 0. The first this one, what do you call this one? Cell, right? So the first cell, basically it is 1. So we will increment the count to 1. This one I'm speaking of. So this is 1 and we will mark this one as visited. Means in this case I'll just give hash so that it is visited. So we will this one increment the count to 1 basically, right? We'll increment the count to 1. This is fine. So we'll call the DFS to sync all the connected ones and then we will convert this one to 0, right? So DFS visits right this one, right? 0, 1, 0, 2 and 0, 3 in this case. So this one has visited, this one 0. Next we'll move one step, this one same, visited 0. Then this one as well. This one visited 0. This is fine. So next, then from 0, 3 it goes down to 1, 3, right? So I'll just come here 0, 3. This one also we have to consider, right? So this one 0. It will go down basically. This is fine. This one we will consider, right? So this one also hash 0. 0 is nothing but after visiting the cell, we will convert the 1 to zeros, right? So that's what we are doing here. Hash is nothing but we are making sure that the cell is being visited. So we don't have to revisit the same cell. We don't have to revisit the cell again, right? So here, then from 0, 3 it goes down to 1, 3. Then left, up, down, exploring, right? Then left, up, down, exploring means here in this case, see, left, up, down, we don't have one here. See here, this one, right? Left, this one, up we have already visited, so it will not be going here also. So in this case, we don't have ones here, so we'll stop here in this case, right? So next, so DFS continues until all the reachable ones are visited and marked as 0, right? So let me come here in this case. So here we have explored right. So next what we will do, will come down here. This one will mark as visited and we'll convert this one to 0. Then again we'll come one more step down here, we'll mark this one as visited and we'll convert this one to 0. Again we'll come right here, we will mark this one as visited and we will convert this one to 0. Next we will move up, we will mark this one as 0 and we'll convert this one to hash. We'll convert this one to 0 and mark the cell as visited by considering hash, right? So this one formed one complete island here, a group of island. This formed a complete one island here, this one I'm speaking of, right? So basically this one, right? This one completely marked as 0. So now all the cells are converted to 0 in the grid. Now you can clearly see whatever the cell that is being visited, we have converted that one to 0 and we have made sure that the cell is visited by marking it as hash here in this case, right? So here now all the cells in the grid is converted to 0 basically, right? Now all the cells in the grid is converted to zeros. So here it says continue scanning the grid until all the cells are already visited. Here in this case, here all the ones are already visited, right? So in our case all the ones are already visited, so no more new islands here, no more new islands here. So the final output that we got is 1 itself, the group of islands. So first we incremented 1, again we didn't find any one different ones, right, to increment. So in this case we got output 1, so we returned the same output here, we returned the same number as output 1 here in this case, right? So the output that we got is 1, which is equivalent to the output that they have given for the example 1 in the question. So the approach works absolutely correct in this case, right? So now we are completely familiar with the approach. As we are familiar with the approach, let's discuss all the edge cases one by one. So the first edge case here is for the all water grid. We have all the water here, so output will be quite obviously 0. We don't have the island at all, right? Land at all, sorry. In this case 0. So here we'll start from here. Next we'll move right, we can move this way or we can move this way finally. So we have only 1 in this case, right? So if we can also move down, right, up in any way, but you can move one step they have given, left, right, this one up or down, right? So this covers after visiting the cell, make sure that we are marking the cell as hash and we'll convert the particular one to 0, particular cell to 0 basically. So in this case 0, 0, 0, 0, it becomes only 1. The group of islands we found is 1 here in this case. So number of islands. So let's come to the third edge case here, diagonal land. Diagonal land we have here, see, 1, 1, right? So we cannot move diagonally, we have to move either left, right, up or down. In this case this will be considered as one island and this will be considered as second island, 2 different islands here, right? So we will return in this case output 2. So we'll return 2 as output in this case, sorry. Yeah, let's come to the fourth edge case, single cell island. So we have only one cell here with the value 1, so output will be quite obviously 1 in this case, right? So let's move on with the fifth edge case here, empty grid. Grid is empty here, output will be quite obviously 0. This is fine. So these are the 5 edge cases that we need to keep in mind, right? So the first edge case is for the all water grid, the second edge case is for all land grid, the third edge case is for diagonal land, the fourth edge case is for single cell island, and the fifth edge case is for empty grid. So these are the 5 edge cases that we need to keep in mind, right? So now we are completely familiar with the approach as well as the what do we call edge cases. So as we are completely familiar with the approach as well as the edge cases, we are good to write the code. Let's start writing. So the first step here is we have to check for the empty grid, right? So let me quickly write the simple if condition here. If grid equals null or length of the grid is 0. So I can just write in this way, right? Grid dot length, if it is 0, then I can just return 0 in this case. Let me return 0 here. This is fine. So the next step here is let's go with the dimensions and counter. Let's initialize dimensions and counter. Here in this case, I'll just go with rows. So let me initialize this one to the length of the grid as well as columns equals grid of 0 dot length. This is fine. The final one is counter. Counter means we have to count the island, right? So I'll just give here island count. This is nothing but the counter island count. I'll just initialize this one to 0. Hope this is clear. Next, we have to traverse the rows and columns, right? And after traversing the rows and columns, we have to find the unvisited land, and then we have to increment the island counter and sync the entire island using the DFS. That's what we need to do. So in simple terms, let's go with here int r equals 0, nothing but this is we are traversing rows here. We are just traversing through the rows. R less than rows r plus plus. Then we have to traverse through the columns as well. So for int c equals 0, c less than columns, let's increment the c, right? This is fine. So whatever means, if we have found the if we find the unvisited land, then we have to increment the island counter. Next time we visit that particular unvisited land, then we have to increment the island counter. So for that one, we have to sync the entire island using the DFS, right? So for DFS, let's write the helper function. Let's take the help of the helper function. So here in this case, first, if we find the this one unvisited land, means I can write in this way: grid of r c. Here in this case, this is equal to 1. Then what we will do here in this case, we have to increment the island counter. So I'll just go with here. Let me copy this one, island counter. This is the counter, right? So this one we have to increment this one, and then we have to sync the entire island using the DFS, right? So for DFS, what I'll do, let's make use of this one. What do we call helper function? So let's write the helper function. Let's perform the DFS and let's make use of the same helper function within the main function. Nothing but num islands function, right? So just give me a second here in this case. Let me come out of this function, and here within this I'll just give private void DFS. So this is char grid int r int c. This is fine. So within the DFS, what we will do, we will check for out of bounds or water. Water means 0, and we will check for out of bounds as well. So let's write the simple if condition here. So if r less than 0, row less than 0, or column less than 0, here in this case column less than 0, or row greater than or equal to length of the grid, this shouldn't be, and also a column as well, right? Column greater than or equal to for this one column, let me consider C itself. We have considered C right here. R and C, sorry. So I should go with C itself. C greater than or equal to grid of 0 dot length. This is fine. Or we are checking for out of bounds or water. For water, I'll just write here grid of R C. This is equal to 0. So I can just write in this way 0. This is fine. So then we have to return 0 in that case. So let me write it here itself instead of opening the flower bracket. This is fine. We'll return 0 in that case. So we have to mark the current cell as visited. Whatever the cell that we visit, we have to mark that cell as visited. So in our case, we went with hash. So I showed with a hash, right? So we have to mark the current cell as visited. So let me do one thing here in this case. Visited means we converted that particular one after visiting the cell. We have converted that one to the 0. I showed with hash because just for the understanding purpose. In this, for this particular problem, what we are doing, after visiting the cell, we are marking that cell as visited, means we are converting that one to the 0, means land to water, right? So I'll just come here, I'll give grid of R C, this one equals 0 because they have given within the strings. I'll just give 0 within the strings. This is fine. So this one also given within the strings, right? Yeah, this is fine. So next, let's explore all the 4 possible directions. We are performing DFS. We have to perform DFS, right? First, let's go with the down here. In this case, recursion DFS of we have the parameters grid R and C. R plus 1 because we are checking down. Next, let's go up here. So let me copy the same thing here. Let me do one thing. Let me copy the same thing here. Make the necessary changes. 4 possible directions we have to explore, right? Here in this case, first one was for down. Next, first one is for down. Next one is for up, basically. For up, what I'll do, instead of plus 1, I'll give minus 1. Next one is for right, basically. So this one will be C plus 1 and column plus 1. So next one is for left. For left, it is C minus 1. So we are exploring 4 possible directions. That is nothing but down, up, right and left. So this is it for the DFS function. We have successfully written the helper function DFS. Let me format the code once. Right. So I'll just come here. We have left our code here within the main function, right? Let me come to the line number 12 basically. So what we were doing, basically I forgot. So just give me a second here. So in this case, so if we have not visited the land, then if we found the land to be unvisited, then we will visit that one and we are incrementing the island counter, right? After that, we have to sync the entire island using the DFS. So we have already written the helper function DFS. I'll just give you we have performed DFS, right? So with the parameters grid C as well as R as well as C. So this one I'll just give R as well as C. This is it. So the final step here is we have to return the total number of islands. So that's what we need to do. In the question, they have asked us to return the total number of islands, right? So I'll just write here in this case return island count. So let me copy this one island count. Let me paste it over here. Simple, right? So let me format the code once and let me hit the run button. I hope this works. Let's see. So we have error here. So I have misspelled rows here and the line number 8. So let me make this one to W. So here we have one more error. Variable rows. This is fine. So let me hit the run button. See if we have more errors. Bad operand types for binary operator. Grid of RC equals 1. Line number 10. So what mistake I have done here? This is correct itself, right? If grid of RC, bad operand types. Grid of RC I have considered right here. This one is just string. You can either consider this one. one. So just give me a second here. What it is saying, char string incompatible types, unexpected return values, incompatible string cannot be converted to. So let me do one thing, let me try this one with single inverted comma. So let me run this one again. So yeah, here return 0 we have. Oh, we don't have to return 0 here, right? We don't have to return anything. So we are going with, we are checking for out of bounds or if it is water, right? So we just have to give return here in this case. So I hope this works now. Let's see. We still have the error here, line number 23. So let me make this to single inverted comma instead of double inverted comma, right? So just let me hit the run button. Let's see. So yeah, now you can clearly see the sample test cases are getting passed. Means the code works absolutely correct in this case. Let me hit the submit button. Let's see whether this works for all the test cases or not. So now you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case. So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is depth first search. We know this one, right? DFS, island, syncing. This is fine. So what would be the time complexity here? The overall time complexity would be big O of m into n. Why it is big O of m into n? Because we are visiting the each cell exactly once. Means DFS marks connected land in big of 1 per cell. So overall time complexity would be big of m into n, rows into columns, right? So what would be the overall space complexity here? The overall space complexity would be big O of m into n as well. Why it is big O of m into n? In the worst case, stack space for DFS recursion. We are making use of the recursion, right? So we are making use of the recursion. In the worst case, the entire grid is land. So if we can have entire grid as land in the worst case, everything is 1, right? So we have already discussed this one in the edge cases, right? In the worst case, the entire grid is land and the DFS may recurse to m into n depth. So overall space complexity would be big of m into n in this case. Easy to understand, right? So the time complexity and the space complexity for the code that we have written is big of m into n. I hope the complexities are completely clear, and I hope whatever the code that we have written is completely clear as well. For now, this is it. Thanks for watching, guys.